As you can see on the first line, let's prove these two limits. So the first limit is x approaches to infinity. The base you have 1 plus 1 over x. The exponent is x. So in this kind of situation where the base has a variable x, the exponent is also a variable x, then the only way to start the first line is you let y equals to the entire function, and then you take the ln on both sides to bring the x down. All right, that is the only way to do it. So this one, we let y equals to the given function, and then we take ln on both sides to bring the exponent down. We have to bring the exponent down in order to do some work. So we, after taking the ln on the right hand side, you bring the exponent down, that because that is the properties of ln. And then what's the next step? This is about limit, right? And then we take the limit on both sides. So we have limit as x approaches to infinity, ln y, and then also take the limit on the right hand side, x approaches to infinity. We have x times ln 1 plus 1 over x. So let's go over what we just did. So we have the base and then the exponent. The exponent is a variable, so we have to let y equals to the entire function, ln both sides, bring the exponent down, and then we take the limit on both sides. Now we focus on the right hand side. So the limit of this is limit as x approaches to infinity. You know what? I am going to rewrite that a little bit because that will save a line for me. So what I am going to erase is I'm going to erase this x, and then instead of doing that x, you know what? Let's just move this up a little bit. Just move this up a little bit so I can get some space for myself. Just change that to 1 over x. Because when you plug in infinity, you will see that there is a 0 over 0. So this is a ln1, right? Because 1 over infinity is 0. So ln1 is equals to 0. 1 divided by infinity is equals to 0. So that tells me I can apply L'Hopital's rule in the next line. Okay, the derivative of the denominator is -1, right? -1 divided by x squared. And then the derivative of ln is 1 over the parenthesis, 1 plus 1 over x. And then using chain rule to take the derivative of the parenthesis, the derivative of 1 is 0. The derivative of 1 over x is minus 1 over x squared. And then what else can be cancelled? I can see that the negative can be cancelled, right? And then other than that, the x squared can be cancelled. And then we rewrite the whole thing. So we have limit as x approaches to infinity. So this is 1 plus 1 over x. And then the top is just a 1. So when you plug in infinity, once again, this line is just rewriting the previous line. I only apply L'Hopital's rule right here. This line is just a rewrite. Just a rewrite, all right? Okay, so plug in infinity, you have 1 divided by 1 plus 0, right? Because 1 over infinity is just a 0. So this is just a 1 divided by 1, that is equals to 1. However, this is not the final answer yet. So we just did ln y, right? So you have limit as x approaches to infinity. You have ln y. The result is equals to 1. That is what we just did. Okay, that is what we just did. And then the base of ln is e. So we have to put this back to exponential form. And then the next line is you have limit as x approaches to infinity. You have y equals to e to the first power, which is equals to e. What is y equal to? You just let y equals to the function at the very beginning, all right? So we are going to put this down back to our conclusion. So our conclusion is you have limit as x approaches to infinity. The y is the given function, 1 plus 1 divided by x raised to the x power, and then overall this is equals to e. So we just proved that the limit is equals to e, and then this one has a name. We call this natural number e as a limit. Natural number e as a limit. All right, the first proof is done. Let's move on to the next proof. The next proof, we have a similar function. This one, the base, we have an n in it. So we let n goes to infinity. So n is the variable. So the base has a variable n. And then the exponent also have a variable n. So in this situation, you have to let y equals to the entire function, and then we take ln on both sides to bring the n down. All right, so we have to let y equals to, the function 1 plus x raised to the n, and then we have raised the whole thing to the n power, and then we take ln on both sides, so ln y equals to, bring the n down, multiply ln 1 plus x raised to the n power, and then we take the limit on both sides. So we have limit as n approaches to infinity, we have ln y, the other side of the equal, we have limit as n approaches to infinity. So this time I'm going to bring the ln down to the downstairs, and then ln 1 plus x divided by n. So when you plug in n goes to infinity, not 1 over x, 1 over n. This is a 1 over n. Change that back to 1 over n. So when you plug in n goes to infinity, the denominator is 0, and then the top gives you ln 1. So this is a 0 over 0, and then we can apply L'Hopital's rule. So draw a big H for L'Hopital. Limit as n approaches to infinity. The bottom is -1, right? And then over n squared. And then the top, the ln is always 1 over the parenthesis. So 1 plus x divided by n. And then the derivative of 1 is equals to 0. I am applying chain rule because you need to take the derivative of the inside, right? And then minus, what was the derivative of xo over n? N is a variable. You have a minus n squared, right? And then the x goes there, and then cancellation. What needs to be gone? The minus and the -1, and then also the n squared and the n squared. So overall, we have limit as n goes to infinity. This we have 1 plus x divided by n, and then the top we have an x in it. So what happens when n goes to infinity? When n goes to infinity, the x over n becomes a 0. So therefore, you only have a x divided by 1, which is equals to x. That is not the answer yet. And then we bring everything down here. So we have limit as n approaches to infinity. We have ln y equals to x. And then as always, the base of ln is e, so we change this back to exponential form. We have limit as x approaches to infinity. We have y equals to e to the x power, so e to the x power, and then you just let y equals to the given function. So therefore, this is limit as x approaches to infinity. The given function is equals to e to the x, and then we just finish the proof. So I write double slash and done. That tells me that the proof is finished. Alright, so that is the end of this video. If you like it, give me a like, share, and subscribe, and I will catch you all in the next lesson. Signing out.